Could there be diamonds on Mercury? The latest image from the James Webb Space Telescope has just changed everything we thought we knew. It showed us that even a simple-looking planet like Mercury could be packed with secrets, such as craters full of potential diamonds right by the sun. This huge discovery hit our screens and proved that our equipment was spot on. What other shocking secrets could Mercury be hiding? Let's dig deeper into these urgent mysteries. A deep space discovery. The first picture we received from Mercury's orbit was stunning. As soon as it appeared on the screen, it was exactly what we had been hoping to see. At that moment, we knew we had truly made it and that everything was working perfectly. NASA had just revealed an incredible discovery from deep space right there on the small planet. Even though it looks plain and sits so close to the sun, Mercury holds dark and potentially valuable secrets beneath its surface, including craters that might contain diamonds. But when we zoomed in, the room fell silent. There, in a crater's shadow, was an unmistakably artificial structure. A secret Mercury was never meant to hold. This small planet, which once seemed like just a faint dot through our telescopes, has become a source of wonder. Thanks to the advanced technology from the James Webb Space Telescope and other missions, we've begun to uncover some amazing findings. Recent studies suggest there could be diamonds deep within the scorching environment. But that's not all. The core is unusually large and strange, making scientists rethink what they know about how planets are structured. We didn't know much about the landscape for many years, but new technology has gradually started to uncover its secrets. NASA's Mariner 10 mission in 1973 was a big step in exploring the planet, and the Messenger mission followed in 2004. As Messenger orbited Mercury, it took detailed pictures of a surface covered with craters and strange ridges, similar to those on our moon. These images showed a dense, crater-filled planet with a surprisingly strong magnetic field and a larger-than-expected core, pushing scientists to reconsider their understanding of the planet. 31 years after the Mariner 10 mission, the Messenger probe gave us a much clearer view of the planet. It stayed in orbit, gathering a huge amount of data and taking over 200,000 images, revealing parts of Mercury that had never been seen before. Among the most interesting findings were high levels of calcium and magnesium on the darker side of the planet. This discovery left scientists wondering how these elements ended up there. On Earth, magnetic fields are created by the movement of liquid iron in the core, but Mercury's unique internal structure creates different magnetic properties. During the day, temperatures can rise to 800 degrees Fahrenheit, hot enough to melt lead, while at night, they can drop to nearly minus 300 degrees Fahrenheit. This huge temperature swing happens because the thin atmosphere cannot hold on to heat. Despite these extreme conditions, recent studies have shown some surprising features on the surface. In 2012, data from the Messenger mission suggested volcanic activity, including signs of explosive eruptions, challenging the old belief that the planet was geologically dead. Scientists also announced they had found water ice in some of the polar craters. These craters are so cold that they keep the ice frozen, even though the planet is very close to the sun. This finding raises even more interesting questions, like whether there could be simple forms of life on the planet despite its harsh environment. Could life exist there? It might sound unlikely, but some forms of life on Earth have managed to survive in the most extreme conditions imaginable. So, it's not entirely out of the question that something could live there, even in its coldest and iciest regions. Right now, a mission called Bepi-Colombo, launched in 2018 by the European Space Agency and the Japan Aerospace Exploration Agency, is heading towards the planet. This spacecraft is expected to arrive in 2025, giving us a closer look at the surface, chemical makeup, and geological history. But the planet keeps surprising scientists. For example, it has a strong magnetic field and even traces of water vapor, which are not things you'd expect from a planet so close to the sun. What's even stranger is the way time works there. Unlike Earth, where we have clear days and years, Mercury's rotation and orbit create a very unusual pattern. For instance, did you know that a year on Mercury is shorter than a day? Mercury breaks the usual rules. It takes only 88 Earth days to complete one orbit around the sun, making its year very short. At the same time, one full rotation takes 176 Earth days, so a single day lasts twice as long as its year. This strange time pattern leads to some peculiar events. If you were standing on the surface, you might see the sun rise, get bigger in the sky, stop moving backward a little, and then continue on its path. This happens because the slow spin can't keep up with its quick orbit around the sun. The slow spin is thought to be caused by tidal locking, a gravitational effect from the sun that has slowed down the rotation over billions of years. Unlike our moon, which is completely locked in sync with Earth's rotation, Mercury has what's called a 3:2 spin-orbit resonance. This means it rotates 3 times for every 2 orbits around the sun. However, that's not the end of the strange behavior. This unique day-night cycle creates extreme conditions on the planet. One side faces the sun for a very long time, getting extremely hot, while the other side stays in darkness and cold for just as long. Mercury also has a very thin atmosphere called an exosphere, which is constantly being lost to space and then replaced by sources like the solar wind, radioactive decay, and tiny meteor impacts. But that's not the worst of it. In 2020, scientists were shocked to find even more water vapor in the exosphere than they had expected. This water vapor comes from reactions between hydrogen from the solar wind and oxygen in the rocky surface. The long days and short years also have a surprising effect on the magnetic field. Despite being a small planet with a slow rotation, it does have a magnetic field, which wasn't something scientists expected. Recent studies suggest that this magnetic field is generated by a special process called the dynamo effect within the liquid metal core. In addition to the magnetic field, Mercury's fast orbit and slow spin cause some truly bizarre conditions on the surface. For example, there are places called hot poles, where the sun seems to freeze in place in the sky, creating the hottest spot on the planet. In the cold, dark areas near the planet's poles, where sunlight never reaches, scientists have found water ice. It's surprising to find ice on a planet so close to the sun, but it exists because of the unusual rotation. Some craters near the poles are always in the shade, keeping them extremely cold. These frozen craters are a stark contrast to other parts of the planet that experience scorching heat. Finding ice has led scientists to wonder if other materials, like organic compounds, could also be hidden in these icy areas. But studying the planet is no easy task. Because it orbits the sun so quickly, this fast orbit, combined with very long days, creates major challenges for space missions. The Bepi-Colombo mission, which started its journey in 2018, is currently on its way to the planet. It uses gravity from Venus and Mercury to adjust its path, and is expected to arrive in 2025 after completing 9 flybys. However, the mission must contend with the planet's extreme day-night cycle. The spacecraft will face intense heat when it's in the sun and needs to conserve energy during the long, cold nights. These extremes push the limits of today's technology and show just how tough it is to explore a planet like Mercury. Recent studies have looked into why Mercury spins so slowly. It seems it may have once spun much faster but was slowed down by the sun's gravity and collisions with large objects like asteroids. This gives scientists new clues about the planet's past and helps us understand how planets in our solar system change over time. Scientists are also fascinated by the planet's huge iron core, which makes up about 85% of its volume. This is much larger than Earth's core, which is only about 15%. Some experts, like Dr. Nancy Chabot from Johns Hopkins Applied Physics Laboratory and Dr. Erica Sog from the University of Arizona, believe it was once a much larger planet. They think it lost most of its outer layers after a big collision early in the solar system's history. But the most unexpected finding was the planet's magnetic field. Even though it's a small planet with a slow rotation, its magnetic field is only about 1% as strong as Earth's. This was a surprising discovery made by NASA's Messenger mission and challenges what we thought we knew about magnetic fields on smaller planets. Dr. Katherine Johnson, a planetary scientist at the University of British Columbia, and her team are still studying this to learn more about the planet's unique features. These discoveries are forcing scientists to rethink their theories about how planets form and evolve. The more we learn about Mercury, the more it challenges what we thought we knew about our solar system. The planet's magnetic field is a bit unusual. It's not centered, but instead shifted by about 1% of the planet's radius. This odd position might be because the crust is not the same thickness all around, which could change how heat flows inside the planet. In 2020, scientists found elements like sulfur, potassium, and sodium on the surface. Normally, these elements would disappear quickly under high heat, so finding them on a planet so close to the Sun was quite surprising. Dr. Patrick Pawlowski thinks these elements might have come from comets or asteroids hitting the planet after it was formed. Another surprising find was water ice and organic compounds in craters near the planet's poles. These craters are shadowed and cold enough to keep the ice from melting. Dr. Nancy Chabot played a key role in this discovery. These same craters may also contain organic compounds, molecules made of carbon. These compounds could be similar to those that started life on Earth. This could mean the planet holds clues about how life began in our solar system. But that's not all. Scientists once believed Mercury was geologically dead. However, the MESSENGER mission discovered signs of recent volcanic activity. They found areas on the surface that might be volcanic vents, meaning the planet is still geologically active. Mercury's south pole is another mystery. It has a wild, jumbled-up landscape with hills and valleys the size of Texas. Dr. Thomas Waters thinks that powerful quakes, triggered by changes in the planet's orbit due to the Sun's gravity, might have created this strange terrain. Dr. Amir Khan studied data from the MESSENGER mission and found that the planet has a liquid outer core and a solid inner core, which is bigger compared to Earth's. This unique structure might explain the odd magnetic field. These discoveries challenge what we thought we knew about how planets are formed and evolve, showing that there is still a lot to learn about our solar system. Now, let's dive into the planet's core and surface to see what secrets they reveal. The planet is about 1,260 miles wide, making up nearly half of its core size. This is a much larger proportion compared to Earth's inner core, which is only about 20% of our planet's total core. Even though Mercury is small, it has a noticeable magnetic field. It's weaker than Earth's, but still significant. Beneath its rocky surface, the planet has a mantle that is much thinner than scientists originally thought. Recent research has found that Mercury's mantle is only about 260 miles thick, which is very thin compared to Earth's mantle, which is around 1,800 miles thick. This thinner mantle affects how heat moves around inside the planet and impacts its geological activity. In 2012, the MESSENGER spacecraft found evidence of past volcanic activity in the form of shallow depressions called hollow. These formed when certain materials evaporated and escaped into space, suggesting there were more volatile elements on the planet than previously believed. But this wasn't the most surprising finding. In 2020, scientists discovered a huge ancient magma reservoir buried under Mercury's crust. This large pool of magma likely played a major role in shaping the planet's landscape and inner structure. It might also help explain some of the unique surface features, like the large flat areas known as the northern volcanic plains, which were likely created by massive lava flows early in the planet's history. Then came a striking revelation in 2022. Researchers found signs of nitrogen trapped beneath the surface. This nitrogen could be leftovers from an ancient atmosphere that was forced underground by extreme heat and solar radiation. This discovery raises fascinating questions about what the climate might have been like in the past and whether it could have once been a more hospitable place. There's even more to the story. Some of the craters hidden from direct sunlight contain ice, which likely came from comets or asteroids crashing into the planet in recent millennia. These craters might also contain dark materials, possibly organic compounds, that arrived in the same way. The presence of these materials provides a unique opportunity to learn more about how organic compounds are spread throughout our solar system. The surface tells a story of its long and complex history, showing key differences from Earth, such as the absence of plate tectonics. Even without plate tectonics, Mercury is shrinking as it cools down, causing many cracks and faults on its surface. These unique features help us understand more about a planet with a fascinating and complex character. In areas where one piece of land pushes over another, large cracks expose the deeper layers, giving us more clues about its geological past. In 2019, scientists made an interesting discovery. They found small narrow valleys called graben next to larger cracks. Graben form when the ground stretches, and their recent appearance suggests that the surface is still shifting and evolving. Another unusual feature is Mercury's magnetic field, which is different from Earth's. While Earth's magnetic field is created by the movement of molten iron in its outer core, Mercury's magnetic field might come from a different source, possibly a layer of liquid metal around a solid core acting like a dynamo. There is also talk of cracks and gaps beneath the crust that might allow heat and possibly even liquids to move through. Although the surface seems lifeless, some scientists think there could be pockets of water deep below, kept from freezing by the remaining heat. This idea isn't as wild as it sounds, considering similar situations on other celestial bodies like Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, which both have oceans beneath their icy surfaces. The possibility of water beneath the dry surface is not out of the question. Exploring these hidden areas sparks our curiosity and deepens our understanding of the ongoing processes shaping Mercury. And here's something to consider. This knowledge might help us learn about geological activities on other planets and moons too. Then, it becomes a vital piece in the larger puzzle, helping us explore and learn more about the solar system and how it has changed over time. But remember, the story doesn't end here. It keeps surprising us. As we learn more, we get closer to understanding the mysteries of our universe. How has Mercury changed on the inside over time? What strange materials might be hidden beneath its surface? What could these reveal about the early days of our solar system and how planets start to form? These are big questions, and they show why we need to keep studying it. Every time we learn something new about what's under the surface, it not only tells us more about this planet, but also helps us understand how all planets come into being and change over time in our solar system. When scientists think about future space missions, they are excited about what they might discover. It might be small and close to the sun, but it still has many secrets to uncover. These secrets could tell us more about what's inside Mercury. By studying these details, we could learn a lot, not just about this planet, but also about others, both in our solar system and far beyond. It might help us understand how planets survive in harsh conditions near their stars and how they stay stable for billions of years. As scientists keep sending probes and collecting data, every new piece of information has the potential to change what we know about space. With its extreme heat and its closeness to the sun, Mercury is a special place to test our ideas about how planets form and develop. The more we learn, the more questions we have, which keeps us curious and drives us to explore it, and other planets even more. Even though it is one of our closest neighbors in space, there is still so much we don't know about Mercury. We still have questions about its surface, its core, and what kinds of processes are happening inside. Scientists think that by studying Mercury in more detail, we might learn not only about its own story but also about the early days of other planets, including Earth. Every new discovery could give us clues about how planets in our solar system, and even in other star systems, are born and evolve. Its harsh environment, extreme heat, cold, and thin atmosphere make it the perfect place to test our theories about how planets form and survive. Scientists want to know how such a small planet can exist so close to the sun for billions of years without being destroyed. Are there special materials inside that help it endure these conditions? Could these materials be found on other planets in other solar systems too? Every new mission to Mercury could change our understanding of the universe. Probes and spacecraft help us learn about its surface, its atmosphere, and what's happening deep inside. As we develop new tools and technology, our ability to explore Mercury improves. Each new mission could bring us closer to solving the mysteries of this unique planet and help us understand more about the universe we live in. Could Mercury hold the key to discovering life elsewhere in the universe?